Okay, so again, doesn't matter in which section you are, whether you're in the online section or the face-to-face section. The way I'm going to measure your attendance is through this class webpage, and this class webpage is on iLearn, right? You just go to ilearn.gavilan.edu, and you're in the class webpage. Okay, if you have logged into the class webpage, I can click and find out what time and how many hours you spend on the class webpage. Okay, so the first thing is, to ensure that I don't drop you, make sure you log into the class webpage at least once a week. Okay, also to make sure that you keep up with the class material, turn in whatever I assign to you by the end of the week. So whatever I assign this week, finish it by the end of this week, so that when we start talking about the new things next week, it makes sense. If you don't do that, you're going to fail the class. Okay, it's treated like a math class. It's not going to be super hard, but you have to keep up with the hands-on assignments. If you don't, you're not going to pass the class unless you're really smart and you can teach yourself programming on your own. Okay, not everybody's like that. Most of them are not. Okay, so it requires commitment, requires work. Make sure you keep up with the assignments. I have a welcome message in there, so why don't I go through this thing real quick. Alright, so the whole thing that I told you, it's an intro to programming. Alright, you can read it at your own time. About the due dates, like I just said, try to turn it in by the end of the week that it was assigned. That being said, I don't like taking points off for things being late. So if you turn in your work by the end of the semester, I will grade it for full credit. Don't take advantage. Okay, I've had students who turned in things all in the beginning of the class. Like one student in the summer semester did everything in 5 days. Alright, you better believe it. And then I've had students who wait until the last minute of the class and then turn in like 70 assignments. Okay, if you do that to me, you're going to lose the privilege of regrade. And what does that mean? For every assignment that I give you the option for me to regrade it for full credit. So you turn it in, it's missing something, I'll leave you feedback, like, oh, you forgot to test it, or you need this and this. You go in there, you fix your program, you resubmit it, and I'll regrade it for you for full credit. Obviously, if you do this towards the end of the semester, I'm not going to have enough time to grade it and for you to use the feedback and then correct your program. So make sure you turn it in on time if you want to use the regrade option. Okay, so this applies to everything except the midterm and final. Midterm and final, I'll also offer a regrade, but I don't give you 100% of the lost points back. I give you 50%. So if you took the midterm, you got 50% on that thing, and I said, all right, you need to fix this and this, and you resubmitted it, now it's perfect, you're going to get 75%. So you went from 50 to 75. I give you 50% of your lost points back on the midterm and on the final. And you're also welcome to just ask me, hey, does this look good, before you submit it? And I'll help you with that too. I'll tell you, yeah, it looks good, or no, this needs to be done, and then you can submit it and get the full points that way. So if I give everybody in the class A's, I don't care, I'm happy. Okay, I did a good job, but it's on you to earn the A's. Okay, I'm not gonna just give them. If you have any questions, send me an email, right? a.stoikov@gavilan.edu. Include CSIS45 and the assignment number that you're asking about in the email, in the subject of the email. I teach a lot of other classes, so narrow it down for me. I have like close to 300 students this semester, or at least 250. I'll answer back to you within 24 hours on a weekday, 48 hours on the weekend. I'm pretty good at answering emails. So if you get stuck on something, send me a question, I'll answer it. Okay? So that's the welcome message. There's also a syllabus. Everything that you're going to need is posted on the class webpage, right? Zoom in on this a little bit maybe. So yeah, the times we meet, if you're in this section, if you're in the Monday section and you want to come to the Thursday section, or you don't want to come at all, that's fine with me. If you're on the online class and you want to come to the face-to-face section to get extra help, I'm cool with that too. So basically, you can come to both sections or to neither. It's up to you. The syllabus, you can read through it. There's some textbooks that are listed in the syllabus. They're not required. Let me see where are the textbooks. Yeah, I've put a couple of textbooks. They're all good. I think I like the Savage, and the primer one's the best. Okay, the Savage is the one in the middle. They're all good books, but you're not going to need a textbook for this class. I'm going to teach you whatever I need to teach you so that you can complete these assignments without the textbooks. Okay? So if you don't have the textbooks, don't sweat it. If you have the textbooks, it will be a good extra reference. If you have some free money to use, get a textbook. If you don't want to spend money, don't buy the textbook. Okay? Okay? So that's the administrative stuff. Any questions? Okay, so there's 16 weeks of the semester. I've gotten most of them ready. There's going to be a lot of assignments, but not an overwhelming amount. It's just basically you're going to have to do a lot of work to, get comfortable with programming. That's the only way you learn it. Okay. All right. So how to contact me, the syllabus, attendance. I went over these things. So next thing, I got to tell you one thing about your grades. All right, we're using this new software called Canvas, which absolutely sucks in my opinion. So let me switch to student view. We used to have this thing called Moodle up until spring 2017, and Moodle is an open source version of this garbage, and it was way better. Okay, but one of the things that suck about Canvas is for you as a student, and I had to deal with a few of these in the summer, it will show you the incorrect grade. All right, so if you go to grades, right, I don't know where it is. There you go. Well, normally this stupid checkbox is somewhere on the top right of the screen, right? Depends on your resolution. Make sure you unclick this. Okay, it says calculate based only on graded assignments. What does this mean? Let's say you can see there's like 60, 70 assignments in the class, right? You turned in 2 of them and they got 100%. This thing is going to show you that you have an A in the class. There's nothing for me to do to disable that feature. It's just there. Okay, and it sucks. So make sure if you want to see your true grade, turn this off. Okay, and it'll show you your actual grade in the class. Okay, so that's one. Another thing is, well, I'll get to that when I get to that. But that's the main thing, right? So make sure you look at your grades frequently. If you submitted something, check to see if it got 100%, so that you're doing the stuff the right way. Okay. Otherwise, you can correct and resubmit it. There's some quizzes here and there, like multiple choice things. I think I've set all of them up to unlimited attempts. So if you take it one time and you don't like your score, take it again. All right? And if it doesn't let you take it again, let me know and I'll change it so you can retake it multiple times. Okay? So that's as far as the quizzes. There's going to be in each of these weeks, there's going to be several assignments, right? So this is week 1. All right, so there's some assignments in here on the bottom. They're all the programming assignments are numbered, right? P1 all the way through P70 or something like that. All right. So this is where you're going to be submitting these, and I'll go through these with you in a second. All right. So I'm using a Mac. You can use Windows or Mac or Linux, whatever you like to write the programs. I have a couple of guides on how to get started with Windows, how to get started with Mac. Okay, on Windows I recommend that you use code blocks. All right, so you just Google code blocks, and there's code blocks IDE, right? And then you want to go to downloads. And you want to download the binary release, and you want to get the one that says MinGW setup, this one right here, right? You can get it from SourceForge. Just download that thing, install it, and once you open CodeBlocks, you're going to have a working compiler. What's the compiler? The compiler is the software that lets you translate your code that you're going to write, your computer programs, into machine language so that the computer can run it. Okay? So make sure you get the one that says MinGW, because MinGW is the actual compiler that goes with CodeBlocks. CodeBlocks is a software where we write the programs, and that software is tied on its back end with a compiler, which is another piece of software that translates the code that you write into a machine language. Okay? If you have a Mac, don't use this because it's very glitchy. I don't know what the newest versions for a Mac are. Let me see if they updated this thing. No, it's from 2013, right? So it's no good. So what I use is I use CLion, right? And that's why in there I have get started with CLion. CLion is actually better than CodeBlocks, and you can use it on Windows or Linux also with your student emails. With the gavilan.edu emails, you can get 1 year free license of this thing. Normally it's like $200 or $300. Plus you get a license to all the JetBrains, which is the company that makes CLion, their other software, right? IntelliJ, a whole bunch of other ones out there. There's like close to $1,000 worth of software you can get for free. Just register with your student email, they send you a license, and the same way that I show how to license this thing on the Mac, same way you license it on a Windows. Okay? And it's very quick for them to send you the license. And the good thing about CLion is, since it's a paid off it's for-profit company, what you can do is you can ask them for customer support. If the thing breaks down on you and you're like, I don't know how this works, contact them, they'll help you. Okay? I've had times when this thing broke on me and I contacted them and they helped me. Okay? Anyway, so that's that. Any questions about anything so far? Alright. 15 minutes in. Alright. So, let's see what else. Okay. So, assuming that you have downloaded CodeBlocks or CLion and you have licensed it, all right, there's some videos in there to get you started, or you can just watch this video here to help you get started. First of all, do you want me to turn off the lights, or is this good? It's good? All right. How about the font size? Is this visible all the way in the back? It's good? All right. So, let me try to... increase the brightness, maybe. No, that doesn't change it for you, does it? Okay. So, all right. So let's start with the first program. So if this is CLion, let me just go from scratch. So let's say I have opened up CLion, right? It might ask you to create a project from the beginning, maybe not. So I'm going to show you how to do it. So you go File, New Project. You have to create a new project with CLion. You don't have to create a project with CodeBlocks. Okay? So if you have CodeBlocks, you just open CodeBlocks, write your program in it, save it somewhere as a CPP file, and that's it. Okay? For CodeBlocks, or for CLion, I mean, we're going to make a new project. It'll be just the default C++ executable. We're going to be using this language standard, C++11. I'm going to call the project, I don't know, Fall 2017. CSIS45. Okay? And that's it. Then I create it. It's asking me a new project can either be opened in a new window. This window, I want to replace this stuff. There you go. Okay, so now it's a new project and it automatically creates something for me. Increase the font size. Normally I can zoom in easy into this, but for some reason now it's not working. There you go, good enough. Okay, so on the left here, you're going to see that it makes a main CPP automatically. Okay, and then in the CMake list, this is where it connects. It basically, we're telling the compiler what to compile, so it's compiling the main CPP, right? So if you're going to create multiple files here, you might have to change this, but for now I'm just going to leave it as is, okay? So I go to the main, and in the main I'm going to add another thing. I'm going to say using namespace std, and then I can get rid of this std here and this here, right? And now we're going to test the program by just pressing this little play button right here on top right corner. Run it, and there's my output on the bottom. Okay, hello world. So the custom is whenever you start with some programming language, get some kind of a message coming out of the program. The typical message is hello world. Okay, so is it working? Yeah, it's working. That program, like the basic things are working, so I'm able to, you know, show some output. Okay, so this is an output. Output is a message that comes out of the program. I put a little comment in here. So this is output info comes out of the program. Okay. What else? What else? So this is how you should start your programs. This is basically the template for every program that you're going to have. Right on the top, you're going to have include IOStream. You're going to have using namespace std. You're going to have this thing int main, and you're going to have some curly brackets, and there's going to be return 0 also. Okay, the main is basically where the program starts. Okay, program starts here. Okay, it's a function. You don't know what a function is yet. I'll teach you functions in like towards week 8 or something like that. Okay, so you need to have a main in any program that you want to be able to run. Okay, so all our programs are going to have main. So we have output, we have main, we have these two. So these two lines are basically needed so that I can use the cout. Okay, so the format, the way you're going to tell the computer to show some information is you're going to tell it cout, and then there's less than, and this endl is, let me show you what it does. So hello, semicolon, cout, right? Okay, so there's a text in quotes. That's called a string, right? So anything in quotes is a string. Anything in quotes is a string. Okay? What's a string? It's text. Text with spaces. It's just a bunch of text. That's a string. Okay? So what I'm doing here is I'm telling it, okay, show this text here, and then show this other text after it, right? And then I'm going to have a cout and cout. I'm going to run this thing. Let's see how it shows. It shows hello world as one big word right here on the bottom. Okay, so what I'm going to do is I'm going to go in there. I'm going to put a little space here. I'm going to run it again. And why don't I put the exclamation on a new line? So I'm going to get this thing here. Cout. The exclamation goes there, and a semicolon. Okay, so I'm going to run it again. Let's see if I can increase. All right, so what it's doing is this endl here, endl causes a new line. And so endl inserts a new line. Okay. You can see that the exclamation was shown on the second line because this endl forced it to go on a new line. It's like hitting the enter in Word when you're typing a text. Okay. What else? So notice that these two, the hello and the world, they're on the same line. If I wanted to insert a new line, another way to insert a new line is if I do \n. Okay. So \n and \n. Right, so both of these insert a new line. Whether you do it with an endl, whether you do it with a \n, the effect is the same. Okay, you're causing something to go on the new line. Make sense? Any questions? We're good? All right. So these are just some basic things with output. Okay. Let's see what else I want to tell you. Okay, Programming style guide. So proper indentation. Oh, something I want to mention. Right. So what I mean by proper indentation is make sure you line up things the same distance from the left. If you notice, when I'm writing my code, all these are neatly lined up. I don't have this kind of a stuff going. So this one is like, say, maybe here, and then there's one, whoops. So C-line is actually going to do a really good job at indenting things for you, so you're going to have to really mess with it to screw it up. All right, but I don't want to see this kind of stuff, right? Okay, so if I see this, you're not following the proper indentation guides that I have in here. Okay, so everything's got to be lined up, you know, indented the same, okay? So that's one thing that you have to watch out for. Another thing is try to make sure that your code fits within this little text window that you have here. Okay? However many characters, let's say around 80 characters. Don't exceed more than 80 characters per line. Yeah. So you can see in the bottom, you can't really see it. Let me zoom in. All right, there's an 868. That shows you that I am on column 68, so I've done 68 characters on that line. Don't exceed more than 80. So that it fits on the same screen, it's easy to read for you and everyone else. Okay, so one thing that I guess I didn't mention is, you notice that I keep running the program and this stuff in gray doesn't show up. Okay, so obviously the stuff in gray, the stuff with the 2 forward slashes, did not affect my program. Okay, so these things, anything that is after 2 forward slashes, notice how it has a different color. Color doesn't really matter, it's just a comment. Okay, so anything, let's go at the top. All right, this is a comment. All right, comment is anything after 2 forward slashes. Okay, so what are comments? Comments are explanation for our code. Okay, that's how you're going to document and explain what your code is doing, what it's supposed to be doing. Some comments that I require on top of your program, you need to have your name, right? Alex S, right? You need to put the assignment number. Let's say this is assignment number, I don't know, P1 or whatever, CPP. Okay? By the way, notice the file that this thing created is main CPP, right? Anything in C++, well, any C++ program is going to have this extension, CPP. Okay? The older C language has the extension of C. So if you're working on code blocks, it might try to save something as a C. So make sure you go in there and type in CPP, because C programs, if you save it as a C extension, it will not work. Okay? So C++ is backward compatible with C, but C is the older language. You can't make it compatible with C++. Okay? So the extension has to be a CPP. What else? So your name, the assignment number, date. I like to have date started and date finished, unless you started and finished. All right, what's today? 28, 29, 28. So let's say 0828 and 0828. Okay, if it took you a couple of days to finish it, put both days. Okay, and description. What is the program supposed to do? Okay, so these comments are part of 30% of your grade. Okay, 30% of your grade will be for the following 4 lines or 4 comment lines. Okay, it might be the most complicated program in the world or in this class, and you forgot these 4 lines. I'm going to take 30% off because I want you to properly document your code. Okay, another 30% of your grade is going to be for comments at the bottom of your code. So these comments that start with 2 forward slashes, these are single line comments. Okay, this is anything after 2 forward slashes is single line comment. Okay, but there is multi-line comments. And what are we going to use multi-line comments for? Well, to show me how your program ran, or if you want to, just do this on a couple of lines. Okay, so C-line automatically starts inserting extra asterisk in there, but this right here, this is the format of a multi-line comment. Okay, so that means that I can copy this stuff here on the bottom. See this whole thing here? I'm going to copy it. I'm going to paste it right here. And I guess you can erase that first line. There. All right. Multi-line comments. This is your program test run. Show me how your program worked. Okay, it's very important in the real world for you to test your code. You're not going to get someone else to test it for you unless you're like really up in the ranks. So you got to show me that your code is working. That's the purpose of this, right? So this is another 30% of your grade is to show me your program worked. Okay? And by the way, what I'm going to do at the end of today, when I'm done with this lecture, is I will post this for you. So if you're worried, oh, I can't take all these notes, I'm your designated note taker, okay? I'll take the notes for you, I'll post this for you, and then I'll put a video that goes, I'm recording all this, so you're going to have the video of that too. Okay? So, but it's good for you to take notes. If writing actually helps you learn and retain the information better than typing. I don't know if you know that, which is way better than just listening. But if you want to just listen, that's fine. Anyway, so comments on top, your name, the assignment number, date started and finished, the description, comments on the bottom. So if you miss any of these two, or if you miss one of them, 30% minus 30%. If you miss the other one, 30%. So you can have the program working perfect, and you're only going to get 40% if you don't submit the assignment in this format. Okay? Any questions? You don't have to all ask at once. All right, so these are the comments that I'm writing throughout my code. They're not required, but I highly recommend that you write comments in your programs so that you can explain to yourself how the code is working. That way, you're not lost when you look at how you did things 3 months from now. Okay, when the semester is over, you should be able to open every one of your programs and easily see what you're doing, what you were trying to do, and how you did it. Okay. All right. So output, comments, inserting a new line with the end L or the /n, right? Output is done using cout and less than, and this stuff in quotes was strings. Okay. So that's one thing. And what else? So I already told you about comments. I already told you about the grading rubric. Let's go through these links real quick to give you some of the terminology. Let me download this thing. And this is from the Savage textbook, all right, which is one reason why I have it on the syllabus, so that nobody gives me a hard time about copyright stuff. All right. So, actually, you know what? I don't want to do this. I think I'm going to let you read this on your own time. Okay, because I have another one that's a little bit more condensed version of this. So you can read this, and there's going to be probably like a little quiz at some point on the PowerPoints, and it'll tell you, okay, this is quiz from chapter 1 Savage. So you open up the PowerPoint, you go through the quiz, and you'll be able to answer the quiz just with the information that's in the PowerPoint. If you don't get something right, you can retake the quiz again. Okay? There you go, that's the shorter version. Okay, so C++ is one of the fundamental languages. You know, a lot of languages are based on C++. Java is based on C++. Okay, and Java is, as far as last time I checked, the highest paid language in this area. Okay, C++ and Python are right after it. Okay, all right. So how things work is we write our C++ program, the little text like the hello world, cout, less than. That's the code. Then there's another program, the compiler that I already mentioned to you, that goes in there and compiles it into object code, and then that object code gets linked with other object code that exists in the language by a linker and turned into a machine language. And what is the machine language? Machine language is just a bunch of ones and zeros. Either something is on or off. That's the only thing that the processor understands, and we feed that information into the processor, and it does all kinds of complicated things like driving a car. Okay? But it all starts with very basic, instructions, and we're starting there. Okay? So you have a compiler, you have a linker, and what we do is we write our code. Our code is going to be written in high-level language. Okay? High-level languages resemble human languages. Okay? So we have low-level languages. If you opened up an executable file on Windows, if you try to open it as a text file, it will look like this. Okay, it's a bunch of nonsense. We can't really read that. Okay, the best thing you can do is there are disassemblers. What you can do is you can grab your executable file and you can turn it into an assembly language. Assembly language is the lowest programming language that we can write in. Okay, I teach assembly, the CSIS28, the computer architecture. That's one name for it. The other one is the CSIS12/12L. That's the assembly. Both of them are pretty much the same thing, so if you take one, it's the same as taking the other. And yeah, writing a program in assembly language is very tedious. Okay, the code is tied to a specific type of processor, specific type of operating system. If you try to, move your code from this computer that you wrote it in into another computer, it's not going to work. Okay, so example of high-level language is Python. Python is even more higher level language than C++. Okay, and how do you do the hello world in Python? You just do this. Okay, there's no main, there's none of that other stuff, no curly brackets. This right here gives you the hello world. If you want to do a hello world in assembly language, you would have to do all this stuff. Okay, so there's a lot more instructions. They are not easy to understand. You do things like, okay, move this variable into this register in the processor, then move this other one into this other register in the processor. Just the process of adding and subtracting is tedious. Okay, so it's really not my favorite language to write a program in or to even teach. Okay, fortunately, we're not in that class. Okay, so high-level languages, much easier to write, much easier to troubleshoot. Programs are more portable. The disadvantages for high-level languages is they take up more memory. They run a little bit slower, but C++ is one of the fastest running programming languages. Okay, in fact, Linux is largely written in C, an assembly language. Okay, so if you're writing an operating system, if you want the thing to run as fast as possible, C and C++ is still a good choice. Okay, and what you can do with C, C and C++ are kind of considered mid-level programming languages because you can still access the low-level features like moving things between memory addresses using C and C++. Okay, interpreter versus compiler. Compiler is what we're going to be using. Remember that picture that I had here? You have a C++ program, then you compile that thing into an object code, then you link it into a machine language. Okay? An interpreted language is slightly different from this. You have your code, you still have your compiler, but then you do not create a final executable file. Instead, you stop right here towards the middle with this object code stage, and then the next part is, instead of a linker, you have a Java virtual machine. For example, Java is an interpreted language. Okay? And what the Java virtual machine does is it reads your object code line by line and executes it, which is different from how a compiled language works, where you have an executable file, which is just a standalone program. You click it, It all happens all at once. Okay. So an interpreted language is a little bit slower. Java is an example of an interpreted language, but the advantage of an interpreted language is it's more portable. You can write one Java program and it runs on a toaster if it can run a program. Okay, that's why Android, a lot of the, well, Android is most of the, smartphone market. Everything in Android is written in Java. Okay, so programs are just a bunch of instructions telling to the computer to do something. Okay. Common parts of a program: you have input, information that goes into the program; output, information that goes out of the program. You can do some kind of a math in there, like adding, subtracting. You can check to see if something's true or false, and you can repeat things a bunch of times. Okay, and then later on you can group things into functions, and then further down the line you can group functions into classes called objects. Okay. Any problem with your code is a bug, right? Bugs are errors. Fixing those is called debugging. There's syntax errors, and let me show you some examples of syntax errors. So for example, if I go in there and I forget to put, instead of two, less than's, I'm gonna do 1, right? And CLine is actually kind of nice because it will highlight things for you. If you're doing this in code blocks, it won't. Okay, in code blocks, you won't get any error until you try to run the program or try to compile the program, and then the error that you're going to get is similar to what you see right down here. Okay? The errors in C++ are not the most user-friendly. It will not always tell you, oh, this is what's wrong with it, so that you know how to fix it. A lot of times it will be a very meaningless error message, and it's up to you to know, oh, I forgot this right here. You basically go with, what line is it? Oh, it's line 17. It will tell you what line it is. Right here on the bottom, it says it's line 17, maybe column 10 or whatever. And that kind of narrows it down. Okay, I have to do this. The way you learn these errors is just by practice. That's why you have to do a lot of hands-on to master the language, to get good at it. Okay? You're not going to get good at this unless you do all the assignments. Okay? And keep up. All right, so this is an example of a syntax error. Another example of syntax error is maybe I forgot, my curly brackets, right? I didn't have 2 curly brackets. If I try to run the program, it will give me a bunch of other errors, right? Sometimes you might have like 50 errors. Don't worry about all of them. Go to the one all the way at the top. Try to fix that, and then as soon as you fix that thing, everything else is going to get fixed. So one error can generate many subsequent errors. All right, so these are examples of syntax errors. So just like the English language has rules, we have to end with a period or whatever, this and that, start with a capital letter. The programming language C++ has its own rules. You have to follow them. If you break them, you break the syntax of the language, and program is not going to run. It's not going to be able to, you can't even get it to run. Okay? There's going to be other kinds of errors which happen when the program is running. Your program runs and all of a sudden it crashes. Okay, those are runtime errors. There's other kinds of errors where you have logic errors, right? You wrote the program, you think it's supposed to do one thing, and then it doesn't because you didn't think it through. Maybe you thought about something the wrong way, or maybe there's something in the code that needs to be changed. Okay, so these are different kinds of bugs and errors. Yeah, so that's that. I think that's pretty much all I want to tell you about the terminology and stuff. All right, hardware programs. What is this here?
Alex?
Yes.
Can you go over the debugging process? Is there a tool we can use to help us debug, not syntax errors, but like actual bugs in the program where doing what we don't expect? It's not doing what we want it to do.
Mm-hmm.
And so how do we go about debugging an actual?
The old school debugging is just throw couts, right? So the easiest way to debug something is show yourself. Let's say, well, we haven't gotten to variables yet, and I'm going to introduce that in a second. But if you have a variable, well, if your program is going to have variables, and chances are your bugs are going to be because you're putting some bad information into these variables, or something's going wrong with these variables at some point. Show yourself the content of the variables. This software does have a debugger. It's a little bit more advanced feature, but I'll tell you what the hell. So if you click here on the side, see this little red dot? That's a breakpoint. And then if you click this little thing here, that little bug, right? Then you can start a debugger. And then you can watch the variables in real time, pause the program, run it step by step. But let's not get into this, okay? But yeah, this thing comes with a very nice debugger, okay? But the old school debugging is you see out things. You show output, okay? All right, so I just mentioned variables. Hardware program, right? Okay, so in case you don't know, hardware are all the physical components of the computer, processor, memory, all the things that you can kick and touch, okay? The software we write are the programs, and yeah, there's input devices like a keyboard, like the mouse, like a touchscreen. Information goes into the program somehow. For most of the things that we're going to do, input is, well, for everything we're going to do in this class, input is going to go through is going to come from the keyboard, okay? But in order for the input to go somewhere in my program, I need to store it somewhere. And where I'm going to store it is the variables, right? So variables is where we store information, okay? Variables are names we make up, right? Such as int age is equal to 10. That's a variable name. So what I'm doing here is I am going to declare, let's do it on two separate steps. So this here is I'm declare a variable with name age to be of the integer type, okay? And I guess I might as well tell you what are the different variable types, right? Okay. So variables where we store information. Data types are the types of information that we can store in our programs. Okay? So what are the data types? So let me do this. Oh yeah. Data types are integer, these are whole numbers. Okay, we have float or double, these are the decimal numbers. We also have char, well, lowercase chart. This is float, maybe make it lowercase, float double, integer. Okay, we also have characters and text. All right, for now that's it. Okay, so we have whole numbers, decimal numbers, single characters or multiple characters which form strings. Those are the text. Okay, text/strings. Okay, so what I'm saying here is this variable called age is going to be of the integer type. Okay, what is an integer? It's a whole number. Okay, so this is declaring a variable. I'm telling the program there's going to be this word that is going to store a whole number in it. What number? I don't know, 10. Okay, now this here is initialize the variable to 10. Okay? Before I give my variable a value, you don't know what's really in the variable itself. Okay? It might be 0, so let me show you. So before I initialize it, let's try to look at the variable. Cout age equals age. And by the way, this is how you show a variable, right? I'm showing some text before it, a little space, and then after that I'm going to show the variable. Okay, let me run it. And actually it says age is equal to 0. Okay, so it actually, the compiler somehow initialize this thing to 0. Don't count on C++ to do this, okay? So don't count on a variable to be equal to 0 initially, okay? A lot of times there's going to be some garbage number in there. That's just the nature of C++. What's happening is we're basically telling, okay, there's going to be this place in memory and we're going to refer to it by the name age, okay? And what's in the place in memory could be some number, could be some huge number, could be a 0. We just looked out that it's a 0 this time, okay? Run it again, right? Age is equal to 0 at the beginning, okay? If I go in there and I move this C out, or put another C out here, now you're going to see that age changed its value, right? It went from 0 to 10. Okay? So that's why it's called a variable, because the contents in it vary, I guess. All right? So some of the terminology: declare a variable, initialize a variable. Okay? So this is a variable of the integer type. Okay? So this is integer variable. Okay? Let's do a float variable, right? And what I'm going to do is I'm going to declare and initialize on the same line. Okay? And by the way, for those of you who have taken Python, this is different than Python. Okay? In Python, we don't declare the variables. We don't tell them what the data type is. And in Python, one variable can change its type to different things, not in C++. If we said it's going to be an integer, it's going to stay as an integer for the duration of the program. Okay? All right. So, float weight is equal to, I don't know, 183.3. Okay? So this is an example of declaring and initializing a variable with the name weight to be of the float type. Okay? So you can do it on two separate lines. You can declare it and initialize it, or you can declare and initialize on the same line. All right. So similarly to this, I can do a float. So this is a float. I can also do a double. Notice in here I said float and double are both decimal numbers, so they have something after the decimal. Double is just a bigger, it allows you to hold more information in content, in memory. Okay, so if one is 8 digits, the other one is going to be, or if one is 8 bits, the other one is going to be 16 bits. Those are not the bits, but just for an example. Okay, so it allows you to store bigger numbers into the variable. Okay. So this is a float variable. You can have a double variable. Double pi is equal to 3.14, right? Whether you use double or float, it really depends on how big of a number you want to store. Okay? If you want to have a whole bunch of decimals, use a double. If you want to have less decimals, use a float. You can have a character variable. Char letter is equal to single quotes. Okay, this is another thing that's different in C++ from Python. If you took the Python, okay, in Python, single quotes, double quotes are the same thing. In C++, there's a difference. Single quotes is a character, double quotes is a string. So I go string, I don't know, text is equal to hello world. Okay? And anything could be in that string. Okay? Any special characters. Okay? And how we show these? Well, we just do cout. The same way that I did a cout here, that's how I'm going to show any other variable that I want. Any questions?
If you try to declare another variable that you've already declared.
Good question. Okay, you're trying to redeclare something?
Yeah.
Error. All right, so I have declared an int age here, right? Okay, then later on, maybe you're like, all right, hold on, I forgot that I declared it double age. Doesn't like it. duplicate declaration of local variable age. So if I try to run the program, it will give you an error. You're trying to redeclare a variable. So if you declared it as an integer, it's an integer for the rest of the program. You can't change it to anything else, in any other way. Okay? You can cast it, which is to force it to turn into something else. But let's not do this right now. So these are the basic data types. Okay? The basic data types were integer, float, character, and text. Right? And this is how you make variables of the different kinds. You can notice that I pretty much make up words any way I feel like it. So in here I said variables are names we make up. So there are rules for the variable names, and they're very similar to the Python business. Okay, so you can't have spaces. Can't have spaces. Okay, so in here I can have A space GE. Okay, you'll think that this is one thing, and then it'll think that the thing after it is a second thing, right? So no spaces in between variable names. Okay, you might have something like first name. You can't have first name be separate, right? Let's call this first name. All right, my string, I can't have it first name like that. Okay, what I could do is I can capitalize every subsequent word's first letter, or I can put an underscore. Okay, so and that underscore is the only special character that is allowed to be in my variable names, right? So no special characters like these here, right? Instead, only underscore is allowed. Okay, so no spaces, no special characters, only underscore is allowed. No reserved words like int, float, main, right? Right? Those that basically change their color, you can't use them for something. Okay, can't use them as variable names. Oh, can't start with a number. Can't start with a number. So I can't have one age. This is bad. Okay? I can do a one age, right? I can do, so these are okay. So this is bad. This, all right? And this is okay is if you do it this way. If you have a one in the middle, that's fine. You can have a number in the middle. You can have age one at the end. That's fine. You just can't start a variable with a number. Okay? You get it. You get an error. Okay? So this is fine. All right. So what happens here? Why did this turn red? Because I changed the variable declaration, right? So I changed this here to a one, to have a one in there, and then if I try to run my code, even if you're running it on whatever compiler, if you try to run it, you're gonna get this kind of an error. Use of undeclared identifier age, which is why it's important for you to know what declare means. Okay, if you don't know the terminology, you don't know what's wrong with your programs. So you're gonna learn by doing. So I gotta go and gotta fix this here. Now they're all matched. Okay, so we know about variables. We know about the rules to name these variables. There's no rule on how long the variable can be. We can make it really, really long. Just try to, make reasonable length variables. Okay, and the last rule is, it's more of a, not that you can, but use meaningful variable names, right? So in other words, if this variable is going to called an age, don't call it num, right? So that when you look at your program and you read your code, it makes sense, right? If you have like num1 and num2 and num3 and one is supposed to be weight and the other one is supposed to be age, you get lost at which variable is supposed to be doing what, or what kind of information is stored in it. Okay, so use meaningful variable names, right? If it holds age, call it age, right? Not num1 or something like that. Okay? All right, so variables, comments, output. Let's see what else I want to tell you. Leave student view, actually go back home. One. Okay. All right. Input. Okay. So the next piece, the last thing that I want to tell you for today is how to enter information into your program. Okay. So let's see where to end this thing. Whatever. There. Okay. So the next thing, last thing I'm going to tell you before I put you to sleep is input. Okay, input is information that goes into the program. Okay, for everything we're going to do, the input is going to be through the keyboard. Towards the end of the semester, I'm going to show you how to read things from a file. That'll be an input from a file. You can have like a sensor that's plugged into your program and your program reads from the sensor. There's all kinds of different inputs that you can have, but we'll keep it simple, just keyboard. Okay, and it's very easy to do input in C++. Okay, so if I just do cin age, just like this, that's my input. It's done using cin and greater than. So cout, information goes out, cin, information goes into the program. Okay? If I run it just like this, this is basically an example of what not to do. So I'm going to run it, and you're going to see that normally, let me just stop this, terminate. Okay, so if I turn this piece of code like so with a comment, and I run the program, there's no input, and the program finishes, right? So it runs all the output, it shows you all the couts that I had, and then it says process finished with exit code 0. Program ended successfully, basically. Okay? Now, if I put this back in, disable the comments, and I run it again, the program is not going to end. Okay? Process hasn't finished, right? It's just blinking there. What is this? Well, it's actually waiting for me to enter something. Okay? So at this point, program waits for me to enter something, then press enter. Alright? So I'm going to go in there, I'm going to do, okay, 100. Alright? That's my input, and then I hit enter, and then the program ends. Okay? So this is an example of what not to do because I didn't know what I'm supposed to enter. So what I'm going to do is, first thing is I'm going to create a prompt. Prompt is the message that tells the user what to enter. And the prompt is just going to be output. Okay? So I'm going to go in there and do the prompt right here. I'm going to say, all right, cout, enter a new value for the variable age, like that. All right, that's my prompt. So when I run the program again, now I get the message, enter a new value for the variable age, and now it's blinking in there, so I know what to enter. Okay, 5, great. Okay. So you asked me, how do you debug? The debugging thing for me is show yourself the information, right? To debug / test your program's input, use cout, right? So I'm going to go in there, I'm going to say, all right, cout age equals age. Basically, show yourself what the user entered. Okay? And they'll run it again. And now it's waiting. 99. So age is 99. Okay? Sometimes you declared this thing was an integer, but maybe you're trying to enter a float into it. And maybe you entered 99.99. Unless you show it to yourself, you're not going to see that it deleted the decimals. Okay? So that leads me to the point of trying to make, let's say I want to make age equal to something else. Okay, so one way to make age equal to something else is to assign it a value. So the equal sign. Alright, so this here is the assignment operator. Okay, I can do things like age is equal to age plus 1. Okay, what I'm telling it here is it makes no sense as far as mathematics is concerned. How can something be equal to itself plus 1? Well, we're not checking to see if it's equal. We're assigning. Okay, what we're saying is this piece is equal to this piece, and this piece could be itself also. So in other words, what this is doing here is we're saying age is equal to the old value of age, which is 10, plus 1, which is 11. So if I run this thing here, see out age is going to show me 11 instead of this 10 here that you're seeing. Now you're seeing an 11. Okay? So that's an example of an accumulation, right? So A is equal age equals its old value plus 1, right? I can also do age plus equals 1. Okay? This is the same as the above. Okay? Age equals its old value plus 1. So if I run the program again, what's the value of age here? 12. Awesome. Somebody's paying attention. Alright, so I'll run it again. Now it's 12. Okay? You can add it by more than 1. You can go by plus more. So let's go and do, okay, age is equal to age plus 100. Alright, so now it'll be 112. Right? Maybe I want to do age plus equals 10. Now it'll be 112 plus 10, 122, right? Hopefully. If I can add right. There you go, 122. Okay? So that's an example of how you can assign values. So you can have multiple things on the right of the equal sign, and you can only have one thing on the left of the equal sign, right? I cannot have something like this. That's a syntax error. Okay? Any questions? All right. What else? What else? What else?
Oh, if you didn't assign age value, you said it would throw in like a garbage.
It
value.
might be. So yeah. So like the example right here. No. Notice how it changed actually. No wait. Yeah. It changed here. See, this used to be 0. Now it's not. Welcome to C++. That's what happens, okay? So be careful. It's not, like I said, it's not a very user-friendly language, and things will crash and not work unless you ensure that you did it the right way. In Java, if you took Java, it makes them all equal to 0 initially. In Python, I think it does the same thing.
Yeah, it does the same thing.
Right?
You have to screw it up.
And C++ this is an old, ancient language. It's not user-friendly. Things will crash and not work, and it's not pretty. Okay, so be careful. So yeah, there's a 1. It could be, sometimes it could be some really, really huge garbage number. Like, make it up yourself. Okay. Okay. So yeah, you have to initialize your variables before you start doing some math with them. Okay. Common mistake is let's say I have, let's say I'm going to have a double area, and I'm going to have a width and height, width and length. Let's call it W. There, width and length, right? And what I'm going to do is I'm going to ask the user, cout, please enter width and length, and then in here I'm going to have a cn for my width, semicolon, another cn for my length. All right, and this is the common mistake. People do this. Area is equal to width times length. All right, and if I try to show the area here, area is equal to area. What's wrong with this picture?
Try working with what you have above first, rather than first.
It will try to, so let's try it. I'm going to try this. Let's run the program. Enter a new variable for age, whatever. Enter width, 10, length, 20. Area is 0, well, because one of these was probably a 0, and I never updated their values. So, for the calculation, I mean. So this is an example of processing, I guess. Processing, right? Some kind of a math we do, which we kind of already did up there with the age is equal to age plus 10, whatever. Okay, but here it is again. So make sure you do this, you know, do it after you get the input, not before, otherwise it's not going to do the correct thing. Okay, so if I run the program again, age again, 10, 20, and area is 200. Okay, so that's one common mistake to avoid. All right. So that's pretty much all I want to tell you. What I'm going to do now is I'm going to go through these assignments real quick, and then, you know, hopefully give you enough clues to get you started on them and call it a day. Okay, so there's a couple of extra credits in there. First one, you have to read a little something. You know, the extra credit assignments, and I'm debating about adding some extra credits, making some of the assignments later on in the semester extra credits. I'll think about it. Okay, but if anything says extra credit, it does not count against you if you don't do it. Okay, it'll only help you grade. This one here, there's a book. You can read through it, chapter 1, and answer this question. Has the processor speed followed Moore's law since 2001? If not, why are processors faster? Anyone know what Moore's law is? What's Moore's law?
It's essentially supposed to be how the number of whatever spiral number are inside the CPU. It's supposed to go up exponentially.
The number of chips that we can put inside of a CPU in the circuitry doubles up every couple of years. So we can condense it and condense it and condense it. And the result of that is technology doubles up in speed every couple of years. Okay, it turns out that it hasn't been observed since 2001 that much. Yeah, believe it or not. And one way to find, you can check your processor specs by looking at the benchmarks, and you'll find out that 3rd generation, 4th generation, 5th generation, and 6th generation processors are not getting a whole lot faster, at least if you look at the benchmarks. So you can get yourself a laptop from like 2012. Yeah, and the battery life is going to be worse, but it's going to be as fast as, or maybe even faster than some of these newer ones, just so you know. Okay, and you can read through this about how they're overcoming some of these, hiccups. Okay, but generally speaking, when we hit the plateau on one type of technology, we come up with something new. So it's getting close to release a new kind of computer architecture processors, so that it gets much faster. They're talking about quantum processors and all kinds of different ones made by graphene. There's another one in here, talks about singularity. This used to be like a really big thing in 2012. Now it's like no big deal, pretty much. So, huh? Depends on who you're talking to. And some people don't buy this at all. But whatever. Some people are stupid. So, anyone seen the Ghost in the Shell movie?
Which one?
Well, there's the cartoon and there's the movie. So either one, they're both the same pretty much.
Do you mean the original anime movie, and then the anime series, or the new live action?
I've only seen the anime movie and I've only seen the actual motion picture, the one that just came out. But anyway, same idea, right? People go and start upgrading themselves and they can learn things a lot quicker, and that's the prediction of Ray Kurzweil. And by the way, if you don't know who Ray Kurzweil is, he's the guy who predicted all kinds of things, including the exact year when a computer is going to beat the human chess champion, right? So he's an inventor, and Google actually read his book about making an AI and made him a project director of whatever he wants. Basically, told him just use our resources and make it happen. And his prediction is by 2025, AI will be indistinguishable in terms of like you can talk to it, chat with it, and you won't be able to tell the difference if it's a human being or an AI by 2025.
Is it bad for me to say that I can actually see that?
You can already see that?
I can see that happening.
Oh, totally. I mean, I don't see why you wouldn't be able to see that. I mean, like this little thing that's in my pocket used to be an entire building in the 80s, and it used to be millions, a lot more expensive than it is now, and so anyway. By 2050, he's talking about the singularity that basically because technology doubles up in speed every couple of years, by 2050, you can't keep up with it unless you start enhancing yourself with that technology. We're already kind of doing that. All right, you're using the GPS, you're using the calendar or whatever. There's all kinds of ways that technology helps us. But this guy's making some crazy predictions, but just go watch Ghost in the Shell. It's the same thing, right? That's in a nutshell. Yeah. Anything that looks like science fiction, give it like 20, 50 years, and it's today's reality. Okay. Anyway, so that is the first couple of extra credits. Just read it, watch the video, write a little paragraph, and you got yourself bonus points. Okay. All right. The other ones. P1. Let's look at it. So P1, type up sample program on display 1.8 in the PowerPoint. Save it, submit it as P1 first program. Append your output at the end of your code as a multi-line comment. So let me show you where that thing is. I think I already had this thing open. No, that's not the one. Download this. Maybe it's a different one. Yeah, it's the same one. Whatever. Okay, so we're going for display 1.8. Where's display 1.8? It's towards the end. Right? That's where the displays are, I think, on this. No, right here. So chapter 1 end is on page 53 of this PowerPoint. This is display 1.1, 1.4. Where's 1.8? There's 1.8, right? So what's display 1.8? It's a program. You type it up, you get it to work, and the output should look like this, right? This is what you're going to copy and paste at the bottom of your code. All right, so for example, this is my program. This is my program output. I'm going to go in there. I'm going to copy this whole stuff here. Copy it. Put it at the bottom of my code. Okay, every program. Okay, so that's that. The easiest thing to do without messing with adding additional files in the project, you can basically create one project with one file main in it, and so you don't have to go in there and mess with the CMake list and complicate your life. I can show you how to do that too, by the way. You can do, just get this whole thing here, put it into like a text editor like Sublime. I like Sublime, right? Sublime works on any operating system. Whoops, wrong one. All right, I get you. Right here. Paste it in there. All right, this is say first program. I'm going to go File, Save As, put it on my desktop. This is my p1.cpp. Right? So I copied everything from C-line. Right? I make sure it works. I put my comments on the top and the bottom. Then I go in there, Control A, Control C, go to Sublime, paste it in Sublime Text Editor, save it as p1cpp, and voila, there's my code. Okay, that's the easiest thing to do. If you don't want to do that, you can go in there and you can add the little files into your project, and you can change the CMake list and tell it which file to run. Right? I'm telling it to run the main in here. If I add another CPP file, I have to tell it run that other one, because it will only run one file. Anyway, so what I would recommend is just write everything here in one main, copy it, paste it in Sublime, save it as the program name, and then you're done. Okay? So once I'm done with this, how am I going to submit the assignment? You click Submit Assignment. You go in there, choose the file, go to my desktop, p1cpp, right? In Windows, you're going to notice that when you compile this in code blocks, there's three files. There's the CPP file, there's the .o file, and then there's the exe. The exe is the executable. The O file is the one with the object code. Remember how it goes from source code, object code, executable? In Windows, you're going to see all these three. Give me the CPP file. Okay, CPP file is the one with the code. If you give me the other two, I can't see what you wrote. Okay, so you get no points for those. And then you submit the assignment, and that's it. Okay, takes its sweet time and eventually does something. Okay, and because of how much Canvas sucks, I have to tell you that if you submit multiple assignments, it will override your old stuff. So let's say you have a programming assignment that asks you to do two programs. You did one of them, you uploaded it, and then you went home, and then you did the other one and you uploaded it. You can't see the first one. Okay? I'm literally going to get on the academic senate to talk smack about this thing. I hate dealing with this kind of, government, campus government. Huh?
Can you record it for us? I have to see this.
You have to see the complaining?
Yeah.
You should see me like going around and telling people about this stuff. You can see it already, actually. So anyway, if you upload multiple assignments, you can't see your work. If and your grade book does not show you the correct grade, okay? Trust me, there's a lot more with it that doesn't work. Oh, and by the way, if you want to buy stock for Instructure, just Google, hold on, Instructure stock. I hope they're losing money. Good. Okay, so look at them. This is what happened. They actually bamboozled the California community college system to switch to their crappy software. So since everybody on the California community college system switched to them, the stock price went up. What's that?
At least it's not Blackboard.
At least it's not Blackboard? I don't know.
Not Blackboard.
It's also not Etudes. There's other garbage content management systems out there, and they're all for profit, by the way. And the one that we were using is called Moodle. It's very easy for you to install it on your server. I have it running on 2 of my servers. Right? It's very quick. I mean, it's just a pleasure to work with this thing. It's been around for 15 years. It was open source, if I didn't tell you that. So I don't know why we switched to it. All right? It was just a very uninformed decision, and I gotta tell people around campus.
I mean, at least we didn't switch to Blackboard, because that's even worse than Instructure, to be honest.
I guess I haven't tried Blackboard in a long time.
Blackboard is the worst thing that's ever graced the internet.
I don't know. Canvas is up there. Okay, so what else? All right, so that was the first programming assignment. Second programming assignment. And by the way, I love the student view. You have to go to settings. Then you have to click the student view. Then you have to go and navigate back to where you were. In Moodle, you can just go click student view right where you are and then switch to student view. You want to turn it off? Turn it off. Anyway, so P2. Write a program that prints out CS in large block letters inside of a border, blah, 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 this, right? All right, so one way to do this is basically, here's your hint for P2. All right, in case you're really lost, but that's okay. So this is hint P2. All right, I'm just gonna paste all that stuff in there. Eesh. All right, and I'm just gonna do C out in front of each of these. C out, and I'm gonna do \n at the end of each of these lines, right? So just copy this stuff, put it in front of each of these, and so on and so on, right? And then put this at the end of each of these lines, right? And you do the rest. All right, so if I run this thing, hopefully it shows right. Not really, but you have to go in there, play around with it. All right, there you go. So it looks like a C. Then paste the right way. Okay, so that kind of stuff. So play around with it until you make a C and an S. Basic baby output. Okay, so that's the first one. The next one after that, P2, P3 actually. Sum and product, write a C++ program that reads into integers and then outputs both their sum and their product. You may modify the program in display 1.8. Remember display 1.8 was this little thing here? Alright? This one shows you how to do multiplication. So use the example to do an addition. Questions? Pretty easy. Okay? And it's going to start easy. And if you keep up with the assignments, it's going to be easy. And if you don't, it's going to get miserable. Okay? This one, write a program that asks for a character input from the keyboard and then outputs a large block letter S composed of that character. So it's basically similar to that other one, except, alright, I'm just going to copy this here. And I'm going to paste it here. Okay, so P3, what you have to do is, you have to replace these, and I made it easier so you don't have to do both of them. You can just do the C. Alright, and you have to change these letters to whatever the user enters. Right? So you can do something like C out, whoops, not here. Well, it won't even matter, but here. C out, enter a letter, maybe some quotes in there. C in. L, I'll call it L, and I have to declare L because I haven't. Cannot resolve variable L, char L. Okay, and then I'm going to go in there. I'm going to replace these with else. L, oops, L, L. I missed my ThinkPad keyboard. I wish I had a ThinkPad keyboard right now. Okay, so and then I'm going to put this in quotes, less than, quotes here. More quotes. And some more quotes at the end. What did I mess up? There's another one here. Another one there. Alright. So, again, quotes there, no, quotes after this. Less than, before and after. And where the space is, let's see if it will do the quotes the right way. Nope. You put more quotes. All the way to there. Okay, so this will work like so. Enter a new value, whatever. Now enter a letter. I'm going to enter the letter A. And now you have the C is going to be made up of whatever the letter the user entered. I know, thanks. All right, so, yes?
Use the cat for class.
Hmm?
Concatenate stuff instead of having all those, that long line, you can't use the concatenate
You can do it any way you want, but that's how I would recommend it. Yeah.
So is it legal to?
Yeah, you can do whatever you want. Yeah.
Okay.
Yeah, this is just early stuff. Just get people comfortable with, just showing variables, basically. Okay, so this is one more, I think, and I'm done. 2 more. Okay, so this is an example of basically make a picture, right? You don't have to be, you don't have to get fancy. You can copy my picture if you want, make it look like a square or a circle. I don't care. Okay, if you want to draw something nicer, go for it. I've seen all kinds of crazy things being done for this assignment. Someone did The Simpsons. One guy did it on one line, so he actually didn't even do it on separate lines. He did it all in one big line.
Oh my god.
Yeah, I think he did Sonic, but with all in one big line.
Please,
Yeah,
I'm not ready to.
go for it.
I'm not ready for that kind
Yeah.
of thing.
I'm not ready to be just.
And then P6, complete at least 2 of these 3 programs. They're all really easy. Write a program that shows as many different words as you can think of that can be formed using only the letters in crate, right? I guess rat, rate, all that's just good stuff. It's simple, okay? They're easy assignments in the beginning. And then write a program that draws a picture of a spaceship. So you already saw an example of a picture from before, the triangle, flip it upside down, I don't know, call it a spaceship. Write a program that shows the longest palindrome you know. You can Google it, I don't care. Just basic output exercises. Okay? That's all you have to do for this week. Okay? So they're easy. Next week they're going to get a little bit more difficult. The week after that a little bit more difficult. And so on and so on and so on. Okay? But the name of the game is keep up with these or you're not going to do well in the class. If you get stuck on anything, send me questions. Don't worry. You're not, bothering me. Just, I love helping students out. So if you get stuck, send me an email. Okay, that's all I have. Thanks for taking the class. Hope to see you next time again.